Good evening, learners. How are you? How are you doing? It's always your mathematics teacher, Mourad Sultan Ezouidi, with you again. Today we are going to apply the discriminant formula of me, and we are going to solve polynomial to the power 5, or to solve the fifth degree polynomial equation. Okay, of course, here in this example, learners, we are going to focus on level A, okay, after that, level B and level C. Okay, means in the resolution or in the solving polynomial, let's say fifth degree polynomial to the power fifth degree equation. Okay, you need to follow my steps. Okay, means you are going to use the general formula of Mourad Sultan Ezouidi. Okay, we start. Learners, here we have polynomial to the power 5. You can see that. Okay, I'll just check my learners to join the lecture. Okay. Give me 1 second, learners. Go to channel Mr. Murad. Okay. Reduce the voice. Okay. And check this. Okay. So learners here today, as I told you that you learn something new, in fact. From me, of course. From not from any other body, only from Mr. Mourad Sultan Ezouidi, the one who discovered this formula. Okay, so learners here, we told that you are going to solve this polynomial to the power 5. Okay, it's not easy, in fact, to solve this kind of polynomial to the power 5. Okay, all the roots here are, let's say, complex numbers. Okay, simply because this is dependent on the, let's say, the sk minus 1 for the r means the coefficient of your new original polynomial. Okay, you can see that this is x5 minus 48x4 plus 960x raised to the power 3 minus 48x squared minus 183,000 and 168 times x, of course, minus, learners, 1,760,256. Okay. Here, learners, you can, if you would like to equate this polynomial, okay, to the, let's say, standard form, you can write it as p of x equal x to the power 5 minus L0 for the q raised, okay, x raised to the power 4 plus L1 for the q, okay, x cubed minus L2 for the q x plus L3 for the q x minus L4 of all the q equals 0. Okay, you know that this is in fact a polynomial to the power 5 simply because learners the highest power is 5. Okay, so we are going to focus on the sk minus 1 of the r, or here it's written sr for the q. Okay, relative, of course, respectively to lr for the q, where r belongs to learners minus 1, 0, 1, 2, and 3, and 4, simply because the highest power is 5, so that's why k minus 1 means 5 minus 1 gives you 4. Okay, means you should find s minus 1, then s0, then s1, then s2, then s3, then s4. Okay? Okay. Now, learners, I will start working on these are the coefficient of my original fifth degree polynomial equation that uh, I will I will find its exact values or its exact roots, okay, without any error estimation approximation method. Okay, so here, learners, you are going to use the discriminant formula of Mourad Sultan Ezouidi, which is written as sk minus 1 for the r equal the sum from 0 to k combination n minus r, choose k minus r, n raised to the power r, between parentheses, learners, negative L0 for the q raised to the power k minus r times lr minus 1 for the q. Always you are going to focus, you are to set k equal minus 1, then k equal 0, then k equal 1, then k equal 2, till you get the 4 in the discriminant formula of me, and you should find the value of sk k minus 1 for the r. Okay, let's start, learners. This example I'm working with you online. Okay, I will use my calculator. You can also use your calculator, Mr. Mourad, if it's possible. Yes, of course, my scientific calculator, I mean. Here, learners, no one can solve this kind of question. Okay, whatsoever. Go travel wheresoever, you'll never find a person or a teacher or a professor doing this kind of problems. Okay, because it's very hard, in fact. Okay, but Mourad Sultan Ezouidi, the Tunisian mathematical teacher, has really discovered so many things, and now he is solving polynomial equation using his own theory. Okay. One time, inshallah, if I find time, I will tell you that I will give you a counter example for Cardan method, okay, and I will give you a new method and forget the oldest one, okay, because the oldest one method, the method of Cardan, let's say, will give you answers or roots with, it will give you, let's say, an estimated root, okay, not correct root, okay, but this method will give you exactly roots as they are, okay. So learners, I'm going to focus on the value of s minus 1. We, by convention, we told s minus 1 is 1, okay. Just replace here, okay, replace, let's say, I just use this one, okay. Replace, learners, k equals 0 in the discriminant formula of me. It will s minus 1 of order r. This is s minus 1 of r. Okay, immediately equal 1. Okay, we can, let's say, jump this one. Also, we can jump, let's say, S0. We told S0 or any nth polynomial equation, the value of S0 is 0, simply because the sum of its x roots is equal to 0. That's why S0 for the he is equal to 0. Okay. Therefore, learners, I will just develop my formula as 0 for the r equal the sum from 0 to 1, combination n minus r, choose 1 minus r, okay. N raised to the power r times between parentheses negative and 0 for the q raised to the power 1 minus r times l r minus 1 over the q. Okay. When r equals 0, learners, you can you can write this as n combination choose 1 n raised to the power 0 times minus l 0 for the q raised to the power 1 times l minus 1 over the q, plus when r now equal 1 and the last one, it will get n combination n minus 1 choose 0, which is 1, n raised to the power 1. This one is going to be equal to 1 times L0 for the q. So this one, after developing and simplifying this expression, okay, you can see this is n minus n times L0 for the q equals 0, okay. So the value of S0 for this new fifth polynomial equation is equal to 0, okay, simply because x1 plus x2 plus x3 plus x4 plus x5 equals 0, okay. Now, learners, we are going to focus on S0 for the, okay. This is a 0, we told negative 5, right, negative 5, Mr. Mourad, times 48, because L0 for the Q is 48, plus 5 times 48, plus 5, Mr. Plus 5, Mr. Mourad, where is plus? Okay, plus 5 times 48. Okay, the Indian people told 48. Okay, the Tunisian people told or pronounce this as a 48. Okay, so this one learns equal to 0. Okay, therefore we can continue, learners. Now I'm let's say I'm trying to find the value of S2. Okay, sorry, the value of S1. Okay, so you are going to learn this to apply or to set k equal to in my discriminant formula sk minus 1 for the equal r from r equal 0 to k combination n minus r, choose k minus r, and raised to the power r between parentheses negative L0 for the k minus r times lr minus q. Okay, after developing this, learners, I'm going to focus on the last one, okay, because this we explained this before, okay. So S1 immediately is equal to this, equal to negative combination and choose 2, okay, times S0 for the Q squared plus N squared times L1. I will use my calculator, learners. These are my coefficient. So it will be negative, okay, negative 10, okay, negative 10 learners times 48 squared, 48 squared, 48, Mr. Murad, yes, 48 squared, plus 5 squared means 25, times 960, okay. This one, learners, equal 960, okay. So this one is equal to 960. I'll just replace this 10 by 48, okay, 48, and this is by 960, 960 equal, learners, with all that is equal to 960. So the value of S1 of order R is equal to 960, okay. So we close this one, learners. We got now the value of S1. I'll check S0. Did I replace? Yes. Here I should replace this one, learners. It will be negative 48, okay, negative 5 times 48 plus 5 times 48, okay. So this one is going to be equal to 0, okay, you can see that. Okay, negative, okay, negative 5, okay, negative 0, okay, negative 5 times 48, okay, plus 5 times 48, 48. Okay, so this one is equal to 0. Therefore, I'm going to write here negative 240 plus 240. This one, learners, is going to be equal to 0. Okay, so we continue. We found now at least 3 values. Okay, I'm going to focus on the third value. Okay, I will try to find the value of S2. We calculate S2. Yes, S2 is here. Okay. S2, learners, to find, let's say, S2, learners, just put K equal 3 in my discriminant formula, okay, in the discriminant formula of Mourad Sultan Ezouidi. This is the discriminant formula of Mourad Sultan Ezouidi, okay. I'll try to insert the text. Okay, I will try, of course, it is possible. Insert the text box, okay. I'll put it here. Okay, so this one, learners, it's written as the discriminant formula of Mourad Sultan Ezouidi, of Mourad Sultan Ezouidi. Means you are welcome to work with my own formula and to get to know about, let's say, nth polynomial equation. Okay, I'll make like that. I will give color. Okay, so we continue, learners. We told that I will set k equal 3 in my discriminant formula. You can see that k I will replace with 3. So 3 minus 1 will give you 2. The sum from 0 to k equal the sum from 0 to 3 because k is 3. Times combination n minus r, choose 3 minus r, times n raised to the power r, times negative L0 for the q raised to the power 3 minus r, times LR minus 1 for the q. After developing this, learners, and explaining this formula, I will just focus on the last one because you can see this. There is a common factor here, L0 for the q raised to the power 3 times, between parentheses, negative combination n, choose 3, it's written here, plus n combination n minus 1, choose 2, times L, okay, then minus combination n minus 1, okay, this is minus combination and so on. Choose 1 times L squared times L0 times L1 plus n cubed times L2. Therefore, I'll just focus on this one. I will tell you this one is equal to 2 or combination to choose 1. Okay? Times combination and choose 3. Times L0 for the Q raised to the power 3 minus combination and minus 2 choose 1 n squared times L0 for the Q times L1 plus learners n cubed times L2. Here, learners, I will just focus on this one, the last one. Means if you are going to work with polynomial equations with the power, with the highest power, you should, let's say, first step, you should work the value of sk minus 1 for, of course, using my own formula. After that, you will enter to a new, let's say, you will enter into a block, okay, of bridges. Means you will get blocks of bridges, and you will choose which bridge you are going to climb or to walk on. Okay, therefore, these for me are the bridges. Okay, and the blocks is that. Okay, so after time with time, I will let you discover so many things, learners. Even in this channel, I can, let's say, I can let you discover, you are going to discover new methods, okay, and standards, new methods, yes, okay. So, learners, we continue. I'm going to focus on the value of S2. I just now replace L0 for the R, learners, is 48. And because this is 48, this is 96. Okay, this is, of course, 48. This is 960. And this one, learners, I'm going to focus on it. Okay. Sorry. L2, yes, L2 is 48. Okay, L2 48 is written here. Okay. I will calculate the value of this. Of course, it has here it has to be equal a value that is different to 0. Okay. Let's work together, learners. We have now okay. 2, okay, 2, okay. 5 choose 3 is 10 because 6 plus 4, okay. So 2 times 10 is 20 times 48 times 48 to the power what, learners? To the power 3 minus 3 choose minus 3 choose 1 يعني 3 times 25 times 48 times 960. This one, learners, I'm going to calculate this. You can see this one, 20 times 48 raised to the power 3 minus 3 times 25, it's written here, times 48 times 960. Then plus what? Plus 5 cubed means 125 plus 125 times 48, learners. Okay, 48. This one is equal to negative 1,238,160. So this one is equal, learners, negative 1,238,160. This is the value of S2. Okay, I will close this one. Okay, now I found already, let's say, S2. It remains only two let's say, values, which are S3 and S4. After that, I can write my new fifth polynomial equation. Okay. After that, I'm going to enter to the block of bridges that I told you, block of bridges. Okay. Means if you reach this level, there are other, let's say, levels. Okay. You are going to go step by step. Okay. So we go to that is negative 1,238,160. Okay. Now, learners, I'm going to find the value of S3. Okay. So to use, let's say, learners to okay. Okay, to find the value of S3 learned, just let's say focus on the discriminant formula of Mourad Sultan Ezouidi, okay, and replace k equal 4. You can see that k equal 4 will give you S3. K equal 4, it will get the sum from 0 to 4. Combination n minus r, choose 4 minus r. Because from the beginning we told that we have to set k equal 4 in the discriminant formula of Mourad Sultan Ezouidi, k times n raised to the power r, of course, r from 0 to 4, is negative parentheses L0 for dq raised to the power 4 minus r times Lr minus 1 of 4 dq. Okay, we can develop this learners. When r equals 0, we'll get 4, choose n, choose 4, L0 for dq raised to the power 4, minus n combination n minus 1, choose 3, times L0 for dq raised to the power 3, times L0 for dq, plus combination n minus 2, choose 2, n squared, times L0 for dq raised to the 2 times L1 of 4 dq, minus combination n minus 3, choose 1, and you bet L0 for dq times L1 plus when r equal 4, it will get combination n minus 4, choose 4 minus 4. 4 minus 4 is 0. That's why this value is 1. And also this one, negative L0 for dq raised to the power 4 minus 4, the power is the index is 0. And L0 for dq is equal to 48, different to 0. So the value of this is 1 times L3, exactly. Now, I will focus, let's say, on the last formula learners that I simplified. Okay, the value, the same formula, the same 3. I'll just put L0 for dq raised to the power 4 as a common factor here. Okay, and then I'm going to find the difference between these two things. So the difference has to be equal to negative combination 3 choose 1 times combination n choose 4 times L0 for dq raised to the power 2 plus learners combination n minus 2 choose 2 times n squared times L0 for dq raised to the power 2 times L1 minus combination n minus 1 choose and combination n minus 3 choose 1 times n cubed times L0 for dq times L2 plus n4 or n raised to the power 4 times L3. I will focus on the last one that had been simplified. Okay, this one, you see, this is S2. This is its general formula for any nth polynomial equation you are going to work with. Okay. Now, learners, I'm going to focus on this. I will replace L0 with 48 and L1 with 960 and L2 with 48 and L3 with negative 183,168. Okay, I'll just cover here. This is, we told it's going to be 10, like 48, sorry. Okay, plus, okay. This is, of course, is 48. I'll just write again the value of LK minus 1 of order R times what learners 960 minus this is 48. Okay, 48. This is learners is, yes, is 48, of course, because L2 is 48 and L3 learners is equal to this one, negative times Mr. Murad, negative 183,168. Okay. Now I will use my calculator and I should find the value of this. Okay. So learners, here, of course, the value of S3 has to be also different to 0. So that the example that I'm given now, it's complex. Let's say it's difficult, in fact. Okay. So to be negative, okay, 3 times 5 is 15. Okay, 3 times 5 is 15. Times 48 raised to the power 4. Even learners GeoGebra, okay, you can put this example in GeoGebra. He will tell you, sorry, you can't solve this kind of question. It's very difficult, okay? Plus learners what? Plus 3 times 25. Plus learners, we told plus 3 times 25. 3 times 25. Okay. Times 48 times 960. This is the square of 48. Times learners 48 squared, of course, times 960 minus what? Minus 2 times 125. Minus 2 times 125 times 48, okay, times 48, simply because L0 of ODQ is 48, or L2 is 48, okay? This is raised to the power 2, here has to be raised to the power 1, okay? Okay, multiply by, we told, by 48, okay? Minus, plus, sorry, 5 raised to the power 4 times negative 183,168. I will put the negative sign in front of uh, the index form here. I would just write negative 5 raised to the power 4 learners is it 625. Okay, times we told 183,168. This one learners has to be equal to that. Okay, so what is the answer, learners? The answer, it's written in front of you, is negative 28 million, okay, 794,240. This is learning the value of S3. Okay, we finished now the value of S3. It remains now, learners, uh, to get S5. Okay, S5, to get S5, learners, you should, learners, find S5 by setting or putting or letting k equal 5 in the decimal formula of Mourad Sultan Ezouidi. Okay, this one is the decimal formula, learners. I'm going to put k equal 5 here. And k equal 5, 5 minus 1 will give you S4. Okay, means you are going to use the decimal formula of me and just replacing k with 5, and you will get the formula of S4. Okay, means S4 equal 0, the sum from 0 to 5, okay, because k is 5, combination n minus r, choose 5 minus r and raised to the power r, between is negative L0 for the q raised to the power 5 minus r times L r minus 1 for the q. Okay. After developing these learners, means you are going to put r equal 0, then r equal 1, then r equal 2, then r equal 3, then r equal 4, and the last one r equal 5 to get this. After that, you can put L0 for the 5 raised to the power 5, L0 for the q raised to the power 5 as a factor like that. Okay, so S4 is equal negative combination n choose 5 plus n combination n minus 1 choose 4 times L0 for the q all raised to the power 5 minus learners combination n minus 2 choose 3 times n squared times L0 for the q raised to the power 3 times L1 plus combination n minus 3 choose 2 times n cubed times L0 for the q raised to the power 2 times L2 minus combination n minus 4 choose 1 times n raised to the power 4 times L0 for the q raised to the power 1 times L3 plus n raised to the power 5 times L4 for the q. This formula, learners, you see this S4 is not randomly it's written like that. No, according to this formula, according to me. Okay, and this S4 for the R, it's the general formula for any nth polynomial to the power nth polynomial equation. Okay, means just if you are going to work with polynomial to the power 2, okay, polynomial to the power 10, 20, 30, 1,000, 1 million, 2 million, whatsoever, trillion, whatsoever, just put n equal to, just put n equal 1 million, just and so on. Okay, so this one never change. This is fixed theorem, fixed discount formula of your mathematical Tunisian teacher Mourad Sultan Ezouidi. And I'm doing this for your sake, learners, to learn things, to learn from new, okay, so many things, okay. So here, after finding the value of S4, okay, we will get immediately enter the block of bridges. Means you are the first level. You should write your nth, your new west nth polynomial equation that had been a relationship between the original and polynomial equation. Okay. After that, you are going to extending the power if it is necessary, because no change. If you are going to solve polynomial to the power 5, it's the same as solving polynomial to the power 6, but the last term is going to be equal to 0. Okay, means this is L4 polynomial to the power 6, L5 is equal to 0 immediately. Okay. So we continue, we'll see this after. Now learners, okay, this is, I'm going to find now the value of S4, last step. Okay, this is we told 48 learners. Okay, Mr. Mourad. This is 48, Mr. Mourad. Good man, yes. Mr. Mourad, okay. This is Mr. Mourad. Is what? Is 960. Yes, 960. Good man. This is 48. Okay. This is 900. Sorry, this is also 48. This is equal to what? I will go down. Okay, go back to your calculator. No, this one change. We told L2 is 48. Then L3 is negative. This is 48. L3 is negative 186. Okay, negative 183. 83,168. Yes. Okay. Then plus 5 times what? Plus 5 times learners. The value of, I will just put this here. The value of L4 is negative 1,760,250. So minus 1,760,256. Okay. Now learners, I will try to find the value of this. Okay. What is my calculator? This is my calculator. I will go here, learners, to appear this for you. Okay. Go again, Mr. Mourad. Like that. Okay, this is S4. I will try to find the value of this. So it will be negative, 4 times 5 choose 5 is 1. 4 choose 1, and 4 times 1, I will make 4, times 48 raised to the power 5. Okay. Minus learners 5 squared is 25, times 48 raised to the power 3. Okay. Minus 25 times 48. I'll put here in front of you so you can see it. Why mouse doesn't work? Okay, it comes. Okay, we continue, learners. We told okay, I will. So 4 times 5 choose 5 is 1, times 48 raised to the power 5 minus 25 times 48 raised to the power 3 times what? Times 960. 960. Okay. Plus 125 times 48 squared times 48 means times 48 raised to the power 3. Okay. Good man. Good man, Mr. Mourad. Okay. Thank you, Mr. Mourad. I love you, Mr. Mourad. Thank you. Okay. We told this one minus 5 raised to the power 4 minus 625. 625 times 48 times between parentheses learn is negative 183,168 between parentheses, Mr. Mourad, negative 183,168. I will close the parentheses. Okay. After that, plus 5 raised to the power 5 times this number. Okay. Plus, Mr. Mourad, means minus. Okay. Minus 5 raised to the power 5. Okay. Times 1,760,256. Okay. So this one is equal learners to what? Equal learners. Just make small. Okay, like that. Okay, calculator. Equal learners, we told that equal. Comes here. We told that is equal to negative 1,855,888,128. Okay, this is the value learns of what? Of S4. Okay, I will try to write it down if it is possible, of course. Okay, equal. Okay, I will do like that, it's better. Okay, now learns, I'm going to write my new polynomial. Okay, my new polynomial learners is equal. Okay, I will just replace, copy this again because I need this. This is my original polynomial I'm going to work with, which is 48. Okay, I'll just write here value negative. Now I'm going to replace sk minus 1 with their own values. This is negative 1,855 million. Okay, 888,128. Okay, this is a value of S4. Okay, this is negative. S4 comes here positive. Okay, this is positive. Okay, I will go now to the value of S3. S3 is that. S3 I will make copy, it's better. Okay, copy. Go down, Mr. Mourad. Okay, S3 told صح. S3 is that. I will write here. Then I'm going to rearrange them. Then S2 will give me S2, the value of S2. The value of S2 is that. I will just make this. Okay. You can see now the value of sk minus 1 of y are all of them different to 0. Meaning that you are going to go to the level B. Okay. I will explain this after. This is S2, isn't it? This is S2 equal. Okay. Now we're going to S1. S1, Mr. Mourad. Go to the value of S1, S1, S2, S1. This is S1. Hurry, please. Hurry, Mr. Mourad. What is S1? This is S1. Okay, 0 is 0. S1, it's here. I'm going to find it out. What is it? Yes, 960. 960. Okay. So S1 is equal to 960. Okay. S2 equal negative. We told 1,238,160. S3 equal, okay, 20 negative 28,794,240. And S4, what is S4? I wrote it somewhere. S4, this one, S4. Okay. S4 learners, where is it? This one, S4 equal to negative. Of course, it's better to write it like that. Equal negative this value. Okay. Now, I'm just now writing the new polynomial. We told and S0 is 0, of course. S0 he learns is equal to 0. Okay. S minus 1 is 1. Okay. I'm going to focus on this. Okay. Now I'm going to write my new polynomial according to this. This is P of x equal x raised to the power 5 minus 0 for the q x raised to the power 4 plus s1 for the qx cubed minus s2 for the qx squared plus s3 or the q times x minus s4 for the q equals 0. So this is the new fifth polynomial equation that you got it or you obtained it from the discriminant formula of Mourad Sultan Ezouidi, from especially from the original fifth polynomial equation that we started with at the beginning. Okay. Now I'm going to focus on this new polynomial. So we can see this is x, this is 0. Okay, I will write 0 or minus 0 times x to the power 4. No need. Okay, but I'm going to explain this. Is plus 960. Okay, then minus okay, minus s2. S2 is equal negative, so here it will be positive. Okay, positive. Positive what? Positive learners. Okay, 1,238,160. Okay. Okay. Then plus S3. S3 is negative already. It will be negative 28,794,440. I will just write it here. Okay, we told the S3 is positive, so it will be negative here. Okay, negative 28,794,240. Okay. Minus S4. The S4 is what? The S4 learners, we calculated this S4. Just comes here, the value of S4, we calculate it here. S4 is negative. Okay. So S4 already is negative, and you give it a positive negative sign, so it will be okay. This is negative, the value of S4, and negative gives you positive. So that's why here it's plus 1,888,128 equals 0. Here, learners, immediately I told you that I'm going to enter to the second level. B, okay, means if you apply the discriminant formula of Mourad Sultan Ezouidi and you do it as it is with no mistakes, this is level A in the blocks of bridges. Means you are going to enter into blocks and you color the first bridge, okay, first level, okay, by using the discriminant formula of me. After that, you are going to extend or to extend your ways of thinking. Okay, to extend your thoughts, to extend your point of view, to extend your behavior, and don't forget to put into consideration the behaviors of nth polynomial equation that will be in front of you in these blocks of bridges. Okay, so you should be very intelligent and very smart to work with this kind of intelligent question. Okay, sorry for being nervous. Okay, I'm at the same time nervous in, let's say, Joker. Okay. So we continue because this is a. If you would like to be mathematics teacher, you should be patient, very patient. Okay, and very and hard working, and don't tell something never happened or now it can't be. No, everything is it had been now. Okay, before it they discovered that there are one or two theorem told that more than five we cannot solve polynomial nth polynomial equation. But me, Mr. Mourad Sultan is a human like you, okay? And now he's training you to work with this kind of question. Now he's solving this kind of polynomial nth polynomial equation, and never no one can no, let's say, abstract or obstacles can stop me, okay? Because I have my own strategies and techniques and theorems, okay, and methods, okay. I'm now applying them. Not only this, there are so many secret learners, but I want to close the parenthesis because the example, we should continue this example, okay? So learners, the roots of this polynomial learners is that is equal. We told that so the roots of this polynomial learners, which is this, okay, it's called x roots. Okay, the x roots of this polynomial to the power 5 learners is or are uh, xk from 0 to 2 equals 6 times cube root of 5096 plus learners, just folks, 1, 2, okay, plus 150 plus a negative, of course, root of 150,343 million 446,496 times exponential 2k plus 1 I pi over 6. Okay, means here you say this 6 means that your mathematics teacher he went or entered in the second bridge. Okay, second bridge. Okay, okay. So therefore, the roots of my original polynomial learners that I started with is labeled as beta subscript k belongs from 0 to 1, 2, ak, equal 48, L0 for the cube, plus xk, ik, which is that, all divided by 6, because I extended this polynomial to the power 6. Ik equal, you can simplify this learners, it will be equal 8 plus cube root of 5096 minus root of 150,343 million 446,496 ik times exponential 2k plus 1 times I pi over 6 ik. This is the roots, the three roots of this polynomial. Also, we have other three roots learners, which are beta, of course, k subscript k, sorry, from 0 to 1, 2 is 48. You see, this is a plus, and this is a plus, but here is a negative sign, and here it's positive sign, okay? So equal, we told that 48 plus 6 times, why we appear 6? Because I want to divide then at simplify by 6. I can appear 6 to the power 4, 6 to the power 5, but here, as I'm going to extend my polynomial, okay, so I should divide by 6. That's why I sorted out here 6, okay, as a common factor, okay. I sort out, I sorted out 216, okay, to the power third gives 6, okay. So we told the plus cube root of 5096 plus root of 150,343 million, okay, 446,496 times exponential. Yes, E is written here. exponential 2k plus 1 I pi over 6. Equal, learners, what? Equal. This one, it will be 8 because 40 divided by 6 is 8. And 6 divided by itself, so it will be cancelled out. Plus cube root of 5,096 plus learns 1,000 root of 1,050 150,343,446,000. Okay, 406. Okay, exponential 2k plus 1 I pi over 6. Okay. Here, you just put, let's say, learners k equal k to get okay. So these are the roots of my polynomial learner k of my original polynomial. Okay, but here you should let's say extract, or you should exclude one value of k, which is 1 or 2 or 3, one of them. Okay, because when you extend the polynomial, this fifth polynomial equation to the sixth polynomial equation, the first root is clear, that is 0. Okay, but here you should exclude one of them. Okay, to exclude this, learners, you are going to use the first one because there is negative sign, and 5,960. Okay, root of this. Okay, will give you a negative 8. Okay, of course, will give you negative 8 raised to the power 3. So it comes here negative. Okay, and comes 0. Okay, means 1k. I thought 1 or 2. Okay. Okay, learners, what else? I will just give this color. Now I will go. Sorry, I will enter learners to the second part, which is very important. Meaning this polynomial, you cannot solve this kind of polynomial if you didn't extend your polynomial. Okay, continue. Now, learners, I'm going to focus on the polynomial that I told that. Okay, this is the polynomial. Okay, I just need this one. What is it? What is it, Mr. Mourad? I need only the coefficient. The coefficient, Mr. Mourad. Yes. The same coefficient. Okay, same coefficient. Let's check same coefficient or different coefficient. 9, 6, 48, 9, 9. Okay. Learners here. I just okay. Okay, I'll start from the beginning. Wait for me, learners. Okay. Till now it's correct. Okay. Now, you see the first polynomial that you started with, its highest is 5. Okay. Now, I'm going to use the same polynomial to the power 5 and extend it. Okay. So these are, learners, okay, the polynomial of what polynomial equation with highest power 6. Okay, so this one at 0 is 48 as before. This is 9060. This is 48. This is negative 183,168. This is 1,670,256. Same example, but L5 is 0. Okay, L5 now is 0 because you are going to extend polynomial to the power 5 to get a polynomial to the power 6. So the last value has to be equal to 0. Okay, that's why here this is 0. Now, learners, as before, okay, to find, let's say, the value of sk, learners, it's clear as 0 is 0 always for any polynomial to the power. Okay, this is for k equal, learners, 1. Okay, you are going to use my discriminant formula. Okay, for when k equal 1, s0 is equal to 0. Okay, if you like to apply, no problem. So just here, okay, I'll just apply the formula now, learners. I'll change color here. I just want you to focus on this on second level. Okay, this is we told it's 0 because you extend this polynomial that we started with from the beginning to polynomial to the power 6, meaning the last term, the last coefficient is 0. Okay, so this one by calculation, learners, it's clear that 0 is equal to 0. Okay, we proceed to continue. Now, learners, we obtain the value of S1. I will just check S1. Okay, S1, learners, is 0. Okay, I'm going to check if it is 0 or not. Okay. Okay, learn this is S1. Of course, we use my discriminant formula. This one learns S1, it's a general formula for any polynomial. It will be negative combination n choose 2 times L0 for d squared plus n squared times L1. This one, it's a general formula. Okay. It's obtained from the discriminant formula of Mourad Sultan Ezouidi. After simplifying, let's say this will obtain that. So I will make here negative 6 choose 2. Okay. 6 choose 2 will be learners. Okay. 10, 10, 20, 20, 3, 4, 5. I'll check here. It will be combination 6 choose 2. 6 choose 2. Last moment. 15. I'll check. So it will be learners erase all of this. Okay. 6 times 5 times 4. Okay, times. Or I will do it like that. This is we told 1, 1, 4, 6, 4, 1. After that, we have 1, 5, 10, sorry, 10, then 10, then 5, then 1. After that, we have 1, 6, then 15, then 20, then 15, then 6, then 1. So here we are going to work with C2. Okay, this is C1, it will be 15, yes. So I'll just write here, learners, negative 15 times 48 squared. 15, negative, of course, negative 15 times 48 squared. Okay. Plus, okay, plus, we told negative 15 times 48 squared plus 6 times 960 plus 6 times 960. This one is equal to, okay, 48, 6, 960. Of course, here in my calculator, what we did exactly? Negative 15 times 48. Negative, okay, okay. Of course, this is 0, Mr. Murad. We told. Okay, we told negative. Okay, 1, 2, it will be negative 15. Negative 15 times 48 squared times 48 raised to the power 2. Correct. Plus 36 times 960. So this one is equal to 0, learners. Okay, the value of S1 is 0. Okay, we continue to get the value of S2 learns. I'll just focus on this formula, this commit formula of Mourad Sultan Ezouidi, last one. Okay, and I will calculate this, the value of it. Okay, here it will be S2 general formula. It's 2 combination n choose 3, L0 for the q raised to the power 3 minus combination n minus 2 choose 1, n squared times L0 for the q times L1 plus n cubed times L2. Okay, I will just use my calculator. Okay, and I will appear, I will try to find the value of this. This is my calculator. Here, learners, we told that, okay, okay, it will be combination to choose 20 means 40 times 48 cubed times 48 raised to the power 3, correct, minus 4 times 36 minus 4 times 36 times 48 times 960. Then minus, learners. Okay, we told minus 4. Sorry, and we wrote 4, and okay, I will repeat again. We have learners. You see this one? 2 times 20 is 40 times 48, 3. So 20, we told, okay, times, I will make times 0, times 0, okay, equal, so only the first one, 4 times 48 times to the power 3 minus, now minus 4 times 36 times 48 times 960, then okay, my plus 6 cubed times 48 plus 6 cubed means 260 times what, learners? Times 48. This one has to be equal to what, learners? Equal to negative 2,201,472. Okay, I'll close this. I'll just close this one. Okay, close this, Mr. Moran. Also close this. I opened it, but it didn't close. Okay, of course, this one, close this one. Okay, now, learners, as we obtained, let's say, the value of S2, we should find the value of what, learners? Of S3. To obtain the value of S3, just put K equal 4 in the discriminant formula of Mourad Sultan Ezouidi. This is the discriminant formula of me, of course. You are going to set K equal 3, and you will get, I will just focus on the last one, on the last formula, which is this, S3, sorry, equal negative combination 3 choose 1 times combination n choose 4 times 0 for the q raised to the power 4 plus combination n minus 2 choose what, learners? N minus 2 choose 2 times n squared times L0 for the q squared times L1 minus combination n minus 3 choose 1 n cubed L0 for the q raised to the power 1 times L2 plus n raised to the power 4 times L3. I'll just make here my calculation. Okay. If you'd like to apply this one, you will get the S3 is equal to 0. Okay. Just I will proceed. This is K equal, okay, K equal here. Okay. Now you should find the value of, learners, of S4. Okay. This is with 0, learners. Okay, you can calculate, or okay, I will calculate in front of you. So we told that this is negative 3 times 15 means negative 45 times 48 raised to the power 3 times 48 raised to the power 4. Okay, plus 6, 4 choose 2 is 6, plus 6, plus plus what? Plus 6, Mr. Mourad. Plus 6, which is this, times 36 times 48 squared times 960. So 6 times 36 times 48 squared, okay, times 960, okay, minus 3 times 216 times 48 squared, okay, then minus what, learners? Minus 1296, 6 to the raised to the power 4, times 183,168. This one is equal to 0, okay? You see, the value of S3 is 0. Now I'm going to focus the value of S5. Okay, learners, here I will tell you something. You see the SK minus 1 of order R related to the newest the newest sixth degree polynomial equation has a relationship between the new fifth degree polynomial equation. Okay, that's why we can get the exits of this new original polynomial from x6 and so on. Okay, now learners, I'm going to focus on S4. Okay, S4. Just put okay, I just place this one. Just put, learners, what? Put k equal 5 in the discriminant formula of Mourad Sultan Ezouidi. Now, when putting k equal 5 in the discriminant formula of me, you will get the last one, which is S4 of order R equal combination. 4 choose 1 times combination n choose 5. L0 of order q raised to the power 5 minus combination n minus 2 choose 3 n squared n cubed. L0 of order q cubed times L1 plus combination n minus 2 choose n minus 3 choose 2. Okay, then learners, I'll check. Yeah, okay, then learners, what? Okay, among us, thank you so much for this enlightening stream, teacher. That's with you are my sunshine. You will never fail to brighten my day. Please keep on making this video. I appreciate your effort. Thank you, Omengas. Okay, thank you for your support. Okay, in fact, I have so many things to do for everybody who is seeks for understanding, let's say, the behavior of polynomial, of nth polynomial equation. Okay, sometimes I didn't find time. Okay, because you know that I have kids and family, and I should support them. Okay, thank you, Among Us. Okay, thank you for that. Thank you. Okay, so we continue learning. We told that L0 of all the. Okay, I will apply this one. Thank you for my own brother. Okay, who just tell me, Mr. Matt, thank you for what you are doing. Okay, so I do appreciate this, learners. Thank you for him also, because sometimes you should okay, I will do it like that. Okay, but I will make it clear for you like that if it is possible. No, like that. Sorry. Mm-hmm. Again. Okay. Control A. So we continue learning. I will subscript full Okay, no problem. Okay, no problem. Okay, so this one is. Hmm, what happened to this? Again, I will reduce this one. Okay, approximately it works. No. So we go back. Okay. Comes here, I will check this one. The size. The size make like that. Control A. Okay, size. Okay. Okay, that is okay. So learners, the value of S4 is equal to 0. Now, I will just now continue learners, okay, because I have something to do else. Thank you for listening, okay. Now, learners, I'm going to do this one. The value of S5 learners is not easy to get it, okay. Just okay. So S5 learners, you are going to put k equals 6 in the decimal formula of Mourad Sultan Ezouidi, and you will get the last formula, which is S5 equal negative combination 5 choose 1 L0 of O dq raised to the power 6 plus n squared L0 of O dq raised to the power 4 times L1 minus n cubed times L0 for dq cubed times L2 plus n raised to the power 4 times L0 for dq raised to the power 2 times L3 minus n raised to the power 5 times L0 for the q plus times, sorry, L4 for plus n raised to the power 6 times L5. Okay, so for that, so this one is going to be equal to 0, okay, because the polynomial, the sixth degree polynomial equation, okay, the last term, the last value, the last coefficient is equal to 0 because I extend this to from a fifth degree polynomial equation. I'm looking for solving it. Okay, okay, Mr. Jalal, this is my eldest brother. He's always he's a good teacher of English. Okay, in fact, I'm learning from him. Okay, I love him so much, Mr. Jalal Sultan Ezouidi, and also my youngest brother Tariq Sultan Ezouidi has a good pronunciation in English, and I appreciate his own pronunciation. And also else, and my brother Makoum also, my sister Huda, my sister Afif Naziha, all of them, Walid Azuz, all of them. I love you, Abdulhab, I love you, all of them, my Kai, because they are my eyes sometimes, I can say, the mountain that I'm climbing, okay, and I'm learning from them. Okay, now learners, we just calculate the value of S5. We got negative, okay, negative 412,289 okay, 679,872. Okay, this is S5. Now I'm going to write my own polynomial learners. Okay, this is my own polynomial. Just a moment. Green, it's better. Okay, here learners. Okay, after finding, let's say, the value of S sk minus 1 of order r, we found S0 equals 0, S1 equal 0, and we find, let's say, S3 is equal to 0, S4 equals 0, except S2, which is equal to negative, okay, I will write it down if it is possible, okay, equal negative 2,201,472. And S5 is learners, okay, is 1,211,619,741,696. Okay, we'll just use the first method. Now we reach the blocks of bridges. Okay, blocks of bridges means the British and the British. British, British, and so on. Okay, okay. There, okay. Now P of x equal x raised to the power 6 minus 0 of order r x raised to the power 5 plus s1 of order r x raised to the power 4. Okay. Plus s3, okay, x squared minus s4 x plus s5 equals 0. All the sk minus 1 equals 0 except s2 and s5. I'll just write my s2 and s5 here. I'll obtain x6 minus s2x cubed plus s4, s5, sorry. Okay, okay. Here, learners, so we just suppose x equal a3 s squared minus s2 x3 raised to the power 1 means put u equal x raised to the power 3. Okay, so your discriminant formula, it will be negative combination to choose sorry sorry s2 of order r raised to the power 2. Okay, I'm going to raise this one to the power 2 plus, okay, okay, plus 4 times s5. I just replace here the value. I will obtain negative s1 of order I equal, okay, 6,494,000, okay, 837 million, okay, 686, 272. Okay, there is no, this is not a comma, okay, it's not decimal point, this is a whole number. Okay. Okay, I'll just make like that. Okay. Here we have learners exactly this one. We told I'll make, okay, no problem. I will make negative, because this is the discriminant, negative 2,201,472,000 plus 4 times, okay, 6,494,837 686,272. Okay, this one has to be equal to, okay, again, Mr. Murad, I will write here. I will put this here. Or down, okay, as you like. Up is better. Okay, what is it? This is my calculator. We told negative 2,201,472 s squared, Mr. Murad, equal negative sign. Okay, plus 4 times negative, okay, this one, there is, I should multiply this by this one. Okay, time, we told 412,089, 679, 872. This one is equal to what? Minus again, Mr. Murat, check again. Okay, S1 minus, I will see the value of, okay, the value of, yes, the value of this, which is S5. S5 is negative. S5 is this one, negative 4, 1, okay. comes here, Mr. Mourad. Make copy. It is better. Okay, copy. Control. So this one is equal to that. Therefore, okay, this one is correct. Now we'll just make it like that. Comes here. Okay, by the way, we obtain this one. I will just extend this one. Look like that. Okay, now it's clear. So we told that we obtain x raised to the power 3 equal s2 minus root of negative s1 of order r divided by 2. Here, let's say our own calculation, we divide this by 2, we'll get negative, 1,100,736. Then we appear here 4, okay, or the root of 4 is 2, and we appear it here. Then we divide by 2, it remains only this one. Okay. So this one, you see the negative sign learns, I will write as exponential I pi. Divide by 2 gives, we'll get 2k plus 1 over 2 exponential I pi. This is x raised to the power 3. Therefore, x subscript k from 0 to 2 is the 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 cube root of this one, means cube root of 1,736, okay, plus cube root of this value, okay, exponential 2k plus 1 I pi over 2. Okay, you can see this one, exponential 2k plus 1 I pi over 2, then divide by 3 will give you this one, exponential 2k plus 1 I pi over 6, okay. So this is xk. Now to find the roots of my original polynomial, okay, or this new polynomial to the power 6, you just make L0 for the cube plus xk, divide by 6. The L0 is 48, divide by 6 will give you 8. And this one we appear here, we factorize, not factorize, to make 216 as a common factor, okay, between these two terms inside the cube root. We'll obtain here 6. 6 divided by 6 will give you this value. Therefore, these are the first three the first three roots of my polynomial to the power 6. And the rest also here x cubed and here x cubed. This is mine. This one has to be positive. Okay, so the same answer, but here sign different. Okay, therefore, the roots of this polynomial learners is that, okay, it's alpha from 0 to 1 and 2 is 0 plus cube root of this value exponential 2k plus 1 I pi over 6. Okay, so you see here we entered to the second level, okay, to solve polynomial to the power 5 by extending this 8 to 6. We can extend this to 7 and we get the same answer, to 8. Okay, but as you are going to apply this, you should think deeply how this works, how polynomial works, how roots works, okay, and not how Mourad works. Okay, thank you and goodbye. Love you so much. I will just save this. Thank you for listening. I am here always to help you. Whatsoever you are a professor in math, I am here to help you. You are a teacher of math, I am here to help you. Okay, you are a student, I am here to help you. You are and wheresoever you are, I am here also to help you. Okay, thank you and goodbye. I love you so much. Thank you. Bye bye. I'll just close this one, learners. Thank you and goodbye. Okay, this has to be closed for let's say a website for giving me chance to continue explaining my researches and discovery in math. Okay, I thank you because we should we shouldn't have something, let's say, especially in science, in math, physics, chemistry. If you have something, try to share your knowledge. Okay, that's however. One day we'll die. Okay, so in this.